Good day, everybody. How are you all? Hope you are doing great today. It is bright and sunny outside my room, and it's very refreshing. And today I'm with you because we want to discuss something about statistical studies. We have talked in the previous presentations that we want to study a sample from a population. We study the characteristics of the sample, such as the average age, but you may have always wondered how to do this kind of statistical study. How do I get started? So, today I'm going to talk about this, okay? About statistical studies. Is that important? Yes, that is important because you always want information through surveys. Okay, you want to conduct surveys and want to get information from your sample. But before I get started, please subscribe to my channel by hitting the red subscribe button. And please also do not forget to click on the notify bell. You will be notified every time I upload a new video. And if you like my presentation, give me a thumbs up. I really appreciate that. I have lots of videos on this kind of material which you can check out in my channel. And without further ado, I will get started, but I will also request that you please stay till the end of the video presentation. It's not long. And also in your comment box, please let me know where you are watching from. I'm always interested to find out where my people who are observing me, where are they coming from? Okay, so where is my audience located? So let's get started without further ado. I'll share my computer screen with you. So we are going to talk about statistical studies, and as the title says, that we have two kinds of statistical studies, observation and experimental. What is the big difference between them? First of all, as I pointed out earlier, that we want to collect information from a sample, possibly out of a population. We do not work usually with population because it's too large and too time consuming. What is a good example of this? We want to collect information about the sample mean age of the students in my sample. So let's get started on that. So observational study, the defining. A study in which the characteristics of a sample selected from one or more existing populations are observed. The goal of an observational study is usually to draw conclusions about corresponding populations or about differences between two or more populations. I know this is a mouthful definition, but the actual point is I have to collect information from my sample. Again, as I mentioned to you, I cannot work with the entire population. Population size is too large, too much time consuming. I would much rather work with a sample which is a part or subset of the population. Now, one thing I must mention, we have to be cautious that we select our sample to represent the population. Okay. So usually we work with a simple random sample. Okay. Next come experiment. So in observation, we are not controlling any factor. In experiment, usually we are controlling factors. So experiment, a study that investigates how a response variable behaves when one or more explanatory variables, also called factors, are manipulated. The usual goal of an experiment is to determine the effect of the explanatory variables, factors on the response variable. In simple language, let me explain. Suppose I have two classrooms, I'm conducting a test on the two in the two classrooms, same time, same college, but I maintain the two rooms at say two different temperatures. On a summer day, I make one of the room very cold, and on a summer day, I make the second room maintain it at normal room temperature without using air condition. So then I will the students go through the test, and I will grade the test After they submit it, I will see, I will compare the difference in average grade between the two rooms. The one at normal room temperature, which is around 75 degree Fahrenheit, and one which is kept extremely cool by using air condition, say 68 Fahrenheit. Is the temperature difference, does it make any difference in the final score of the students? Is the room where the temperature is controlled by air condition, keeping it down, substantially down from the normal temperature, does the student perform better in a cooler temperature in a test, or in a room temperature, ambient room temperature, which is 75 A? So my goal in this experiment is to study the effect of temperature, room temperature, on the final score of the students, on the score of the students in the test. Examples of observational studies: estimating average shell thickness of bald eagle. Here we are not controlling any extraneous factor. Here we are not controlling any factor. We are just measuring the shell thickness of eagle eggs, studying the relationship between age and altitude and attitude, sorry, toward abortion in a rural community, age and attitude. Okay. What are the examples of experiments? Investigating the impact of lab time on test scores in a chemistry course. What do they mean by that? You can have two chemistry course sections. One section get an extra hour of lab time. Another section which is does not get the extra 1 hour of lap time. They just have, say if the lap time is 3 hours, so the control section will have 3 hours of lap time, the other section will have 4 hours, extra 1 hour. Does that extra 1 hour of lap time improve their score in the course? Comparison of test scores under different lab time competition conditions. This is much like the room temperature experiment that I talked about. Different lab time conditions, do they have uh, different final scores in the course? Observational study versus experiment. In an observational study, clear cause and effect conclusions are challenging. Why? We do not know what causes the response variable to change, because we have not controlled any of these variables, any of the factors. So exact cause and effect conclusions are challenging. Experimentation provides a distinct advantage in establishing causation. For example, in my example, I'm mentioning it again, does temperature make a difference in room temperature, make a difference in the score in the test? Okay. Does the room temperature, do the students perform better in a cooled room, cooled below the ambient temperature, or do the students perform well when the room temperature is not controlled, it's kept at ambient temperature? In some cases, there may be a confounding variable. What is a confounding variable? It is a variable or a factor that confuses the result. A variable that is related to both the experimental group that were formed and the response variable. So it's a variable related to the experimental groups as well as to the response variable which we are measuring. Different types of conclusions have been described. Okay. Generalization to larger population involves extrapolating findings from a sample to a larger population. What is an example of that? I selected a simple random sample of 50 students, asked them their age in years at their last birthday, 50 numbers, add the 50 numbers, divide by 50, I get the sample mean age. Okay. So from that, I make an educated guess about about the mean age of the entire population of students. Is that going to be good? My educated guess may or may not be, depending on how the sample was selected. Was the sample selected as a simple random sample? That will make a big difference. The sample should represent the characteristics of the population. So that is generalization to a larger population. Number two is cause and effect conclusions. Focus on establishing a cause and effect relationship between variables. Key consideration impact of explanatory variable on the response. Example of that is two rooms at the same one at the normal ambient temperature, the other kept a little few degrees cooler by air conditioning. Will that affect the test scores? So, is the test score dependent on the room temperature? That is the question we are trying to answer. Okay. So, drawing conclusions from statistical studies, observational study with samples selected in random from the population of the. So, we are selecting sample from the population. uh, the sample is selected, simple random sample. Can we generalize the conclusions about the sample characteristics to the population? Because in the first category, because the sample was selected randomly, we can generalize the results from that sample to the population. So under the first column, generalize the results, and your response is yes if the sample was selected by a simple random method. Reasonable to draw cause and effect conclusion? No, because this is an observational study. We cannot do cause and effect conclusion. Observational study based on convenience or voluntary response sample. Voluntary response sample means some people out of their own will, they want to participate. These people do not represent the population. Okay. Therefore, we cannot generalize the results from the sample to the population. No. And reasonable to draw cause and effect conclusion? No. So second row, where the sample of convenience is a sample that is convenient to me, convenient to the person who is doing the study, such as if I select only students from my class, they do not represent the entire population. You ask why? Because not all students in a college have to study statistics. Okay. Therefore, no and no in both columns in the second row. Experiment with groups formed by random assignment of individuals or objects to experimental conditions. Okay. And then the next one is individual or objects used in study are volunteers or not randomly selected from. Okay, then you can generalize. You cannot generalize the result from the sample to the population because the sample was not randomly selected. Can you draw cause and effect? Yes. Individual or objects used in the study are randomly selected from some population. Then, because the sample was selected by a simple random process, you can generalize from the sample result to the population. You can also draw a cause and effect conclusion. Experiment with groups not formed by random assignment to experimental whenever you have non-random selection of a sample, you cannot generalize to the population results from the sample, or you cannot draw a cause and effect conclusion. So the key message they're giving is that the sample should be selected randomly from the population of interest, and the sample should represent the characteristics of the population. Okay, the sample should not be a sample of convenience or voluntary response volunteers. Okay, so I stop here today. Okay, I stop here today. I stop here today. If you have any question, please do not hesitate. I'm telling you, please do not hesitate to write it in the comment section. I will personally answer each and every question. And if you like this video, please give me a thumbs up. If you want your friends to know about this video, please share this link with them. And please subscribe to my channel by hitting the red subscribe button. And please do not forget to click on the notify bell, which will notify you every time I upload a new video, which I do almost every day. And please come back. Do not forget to come back tomorrow when I will load another new video, upload a new video. Thanks for watching. I really appreciate it that you take time off and listen to my video. Take care. Have a nice day. And definitely, I'm going to see you next time. Take care. Bye.